Hi guys, welcome to the next video of my NLP series. So guys, last time we discussed in the last two lectures we are discussing how neural networks work and how essentially you have forward pass of the data, then you have a loss function which gets optimized, and you have backward pass of weights, and essentially your weights get updated. So guys, this much knowledge is okay for a theoretical level, and in whichever topic I feel we need to go in deep, I'll go there. And guys, more or less the main idea is to quickly get your hands on modern NLP, specifically NLP tasks when it comes to LLMs. And yes, we haven't started doing it, but we'll start doing it. It's more like a ground laying stone. And yes guys, in depth I'll create one video for transformers very soon. But essentially in depth, if you'll study RNN, LSTM and transformer, this would take a lot of time. So for the time being, let's stick to development and transformers only. And obviously everything will come on my YouTube channel little later. But guys, the main idea is to get you perhaps a job first, and then maybe whatever time you have, you can go in as much depth as you want. So but today we'll be discussing about a comparison between three things. One is RNN, LSTM and transformers. So guys, essentially all three are a type of neural networks only. Okay, nowadays essentially we are using transformers when it comes to training LLMs. Okay, that means the base architecture that is used to train LLMs is transformers. And as I've been saying in my NLP series, that the main goal is to just predict the next token. Okay, the main thing is that with how much accuracy you're trying to predict the next token, that's pretty much the main saga of the story. And very important context is that how did we move from RNNs to transformers. So see guys, these are three architectures. Okay, now what is the architectural complexity? So that guys, it's more like simple, moderate and complex, which is not exactly true. Even RNNs can be a lot of complex. If you'll see bidirectional RNNs, the way information flows, specifically when it comes to coding it from scratch, could be a nightmare. But yeah, you don't need to do all of that things, that's fine. Long term dependencies. So guys, I in my course have been focusing a lot on this fact, that how long term dependencies are handled. So what are long term dependencies? So let's say guys, you have a novel. Okay, and the plot of the novel is that there's a girl, and she's liked by three boys. And after that, all three boys get a chance to impress her, and now she will choose one boy for marriage. So guys, let's say you give this task to an LLM and say that hey, you need to predict that which boy the girl will get married to. So guys, for these type of tasks, right, these are not this novel, the LLM, this exact novel wouldn't have seen in the training data set, right? This is a new novel that has come up. And for it to understand that to which guy the girl will marry, it needs to have an understanding of long term dependencies, right? Because essentially a novel can have 200 page of text, and if one page of text could be, say, 500 words, then you are just seeing that how much data is there, and you need to have a model which can handle long term dependency. And guys, even that, but the main thing is parallelization. So guys, essentially transformers allow you to use GPU in the best possible way. So you can just parallelly have multi-head attention layers running, and then you can just combine them. Okay, that's the main power of it. And in general sense also, right, if any task in your life is done with the help of parallelization, it wins. Then what is the training speed? So guys, training speed is there, that RNNs fast, slow but highly parallelizable. But guys, this is not a very important parameter. The main thing is scale, right? If you have a very deep neural network, on top of that you have a lot of data sets, then obviously it takes a lot of time to pre-train a transformer. Then memory consumption is fine guys, you can skip this point. Now let's just move to RNNs a bit. So see guys, RNNs were there initially, they came out, and they basically are a class of neural networks which are used to work with sequential data. So I in my course have used this word sequential data as well. So sequential data is the data where sequence matters. So essentially, let's say a time series data, right? Let's say what I'm talking, the sequence matters, right? You cannot just start and mix words from anywhere. So essentially, guys, you give your input to an RNN. Okay, you give an input to your RNN. Okay, it creates a hidden state. This hidden state gets updated at every input, and then that thing gets passed to the RNN itself. And if you can't understand this type of things, it's okay for the time being. Now no one is using RNNs, that's what I believe. But guys, there are few people who are even working to make RNNs better, so that's okay. But yeah, the main idea is that they process input sequentially, and thus scaling RNN was always a challenge. Okay, and the main thing was also that they suffer from vanishing and exploding gradients, and they struggle with long-term dependencies as well. So long-term dependencies we have seen, vanishing and exploding gradients we'll see guys. What happens is that if you have a very deep neural network, right, and you keep on applying back propagation from this way, right, you go from right to left, you're just going applying, and then due to chain rule, what happens is that the gradient tends to become very slow, and it gets small and gets approximated to zero. So then if you have seen my playlist, I've been writing w new is equal to w old minus eta learning loss function, rate of change of loss function with respect to weight. So guys, this parameter, that is this thing, would almost tend to zero only, and thus your weights don't change. So that's essentially vanishing gradient, and an exploding gradient, they become too big to handle. So that's there. Then guys, LSTM came, and LSTM introduced the concept of gated mechanism. This helped them capture better long-term dependencies than RNN, and they are slightly more complex than RNN. Yes, they are computationally expensive and don't support a lot of parallel things, but yeah, they are good in doing some tasks. So earlier, a lot of people in industry believe that LSTMs, they used to train LSTMs for specifically like time series problem, and yeah, they used to do these kind of things, but that's okay guys. You can simply use the library and get these things done. And they use the concept of gates, which really improve the fact that then how does information gets passed to the decoder layer. But again, as I said that LSTMs are also now less used than came in the transformers. So see guys, transformers are an engine. Okay, it's not just a neural network architecture, it's very powerful. The main idea is, obviously we'll have a separate video on transformers, but I thought of just giving you a glimpse of all three of them theoretically, so that once we do any sort of NLP task, you won't feel vague. And yeah, at least for a theoretical layer, this much knowledge is enough. We'll go in depth as and when I feel that hey, this is something we need to know. So see guys, transformers are quite a phenomena. Okay, transformers are like the brain of any modern neural network that's get trained, and they heavily relies on attention mechanism. So see guys, what is attention mechanism? Now what does attention mechanism do is, let's say we are doing a task of translation, that is English to Hindi. Okay, and you have a sentence that uh, how are you, this is the sentence. So in Hindi it is aap kaise ho. So this is how are you, and this is aap kaise ho. So let's say you're doing a machine translation task, and how needs to be converted. Now understand guys, how in Hindi is not aap, right? So you need to understand one thing, that one, like this thing, like once let's say aap gets generated with, then the model moves to generate kaise. So it needs to focus on how, right? So it needs to have some mechanism that essentially forces, when the next word is getting generated, it should point out to how, because how should have a higher importance in generation of next word, and similarly it happens. So attention mechanism is the main backbone of transformers which helps some part of sentence. Like once you're generating tokens, right, you need to focus on some part of the sentence which is more relevant than others while generating context, right? Like I said, that let's say once app gets generated, whenever you're generating cache, the model should have a mechanism to focus more on how than RNU, and then the same way happens. So that's attention mechanism. Obviously in the transformers explainer video I'll be covering that as well. And essentially guys, this is very important. Okay, now you're able to handle long-term dependencies. Things are very parallel and they are having state of art performance on a lot of NLP tasks. Yes, they are complex in nature, require a vast amount of data and computational resources, may struggle with long-term dependencies. That's okay. But guys, transformers in itself are a complete system. Let me just share some more light on transformers as well, because guys, slowly you'll have a separate video for transformers, but you need to start from somewhere. If you'll directly jump into the maths, it would become a little overwhelming for you. And like once you're first time studying NLP as a beginner, you don't need to like go in depth of it as well. It's okay, you can take your time and learn things. Okay, so guys, whenever you find a research paper, I think they are have, yeah, so whenever you find a research paper, at least start by reading the abstract first. So let's just read the abstract for transformers. The dominant sequence transduction models are based on complex RNNs that include encoder and decoder. Okay, the best performing models also connect. Let me just cancel this. Let me just use eraser. Mm, okay, no. Okay, where is the eraser? Eraser. Okay, I can't find the eraser. Okay, let me just use a very simple color pencil. Yeah, guys, sorry. Just okay, let me go to pencil. Yeah, so let's just read this once. So we'll read this once. Okay, because if you will at least start by reading the abstract, you will gain some knowledge and later on we can scale it up. So guys, let's just try to read the abstract. The dominant sequence transduction models are based on complex recurrent or convolutional neural networks in their encoder and decoder. So guys, as I said, you have an encoder network. So your input comes, then a vector gets created. This vector gets passed to the decoder network and the decoder starts producing output. Okay, so that's how things are there. The best performing models also connect encoder and decoder through an attention mechanism. Okay, so as I said, that attention mechanism is the mechanism in which essentially the words tend to focus on other words which are very important. As I gave you an example of how are you and aap. Okay, aap kaise ho. So once you are generating this word, right, kaise, let's say aap gets generated. Whenever kaise was generated, you should have a mechanism that would let the model focus more on how while generating kaise. That's essentially the attention mechanism that helps like words in the sentence to focus on relevant portion based on context. So they are saying we propose a new simple network architecture, the transformer, which is based solely on attention mechanism, dispensing with reoccurrence and convolution entirely. So guys, in this baseline, they are not using RNNs anywhere, nor they are using CNNs anywhere. Experiments on two machine translation tasks show these models to be superior in quality, more parallel, and require significantly less time to train. Our models achieve this score. So guys, they are all saying that how transformers was able to achieve a higher blue score. So guys, blue is a metric that is used to just tell you how effective your translation is. So there they, in this paper, they had taken the task of English to translate English to French translation task, and they have improved on the, they got a state of the art blue score of 41.8. So guys, essentially you are able to see, right, how to start understanding things. Slowly everything will get covered, but yes, development is of prime importance to us. So that's why I just wanted to give you a good glimpse of how you could just understand and just try to get along with these terminologies. Slowly everything will come, but don't worry guys, not in-depth knowledge of anything is required when it comes to let's say building up any application. Whatever is required, I'll be covering up in this playlist. So thank you guys, and please subscribe to my YouTube channel. Have a great day ahead.